Hello, this is the Question D brand new Tatar TV show from the most recent Division 3 contest. And basically, you're given an array of numbers, and there's two characters, Dabir and Igor. But there's also another character called Arseny, I think. And Arseny wants Igor to win. So the way that operations happen is once someone makes a move, they choose an element equal to x, and the next person who makes the move chooses an element y, but this y has to satisfy this, so the difference between y and x has to be smaller than or equal to k, and also bigger than or equal to 0. And you want to see if there exists a solution so that Arseny can pick the first value, and after Igor moves, and he wants Arseny chooses the first value, and Arseny wants Igor to win. So we want to see if it's possible for Arseny to make it guaranteed that Igor wins if Arseny chooses the first value. So, for example, let's look at the first no this test case 411311. Here, k is equal to 1, and a way that let's just think, what if Arseny took the value 3? If Arseny took the value 3, Agor has to take a value that is greater than or equal to 3, but also smaller than or equal to 4, because k is equal to 1, and y has to, uh, since y is the value we're picking. But since there's no y that's bigger than 3, we know that Arseny can't pick 3. So what if Arseny picks 1? Okay, Arseny picks 1, then let's say Igor also picks 1 because that's the only other option, and after that, Dabir picks the other one. Now Igor needs to pick a value, but Igor can't pick 3 because 3 minus 1 is equal to 2, and 2 is bigger than k. So this is not possible, and that's why the answer is no. But let's look at the next one, 51515115, where k is equal to 1. And what we can notice is that if Arseny picks the value 1, and Agor picks the only other available option, which is 1, Agor wins because Dabir can't pick anything else because 5 minus 1 is equal to 4, and 4 is bigger than k. So, yeah, this works because this, yeah, as I just demonstrated, if Arsene picks 1, then Agor wins. So what we can realize is that we can split up our array into chunks. So for example, this array right here, we have 5, 1, 5, 1, 5. We can split it into chunk for 1, 1, 5, 5, 5. And what I mean by a chunk is that, let's say I picked a value from this chunk right here. So let's say I picked this one right here. If I pick this value 1, then I will never be able to pick a value from this other chunk. And that's because the distance between the largest value right here and the smallest value right here is bigger than k, which is equal to 1. So that's the definition of a chunk. We want to split them up into chunks so that the largest value in a chunk so that the distance between the largest value in a chunk and the smallest value of the chunk to its right will always be bigger than k. And another thing we can realize is that, for example, in this chunk, let's just say what we can realize is if the amount of largest values in a chunk is even, then we know the answer is always yes. So let's say we looked at a chunk right here, 1, 2, 5, 5, 5, 5, 5. This is there's more to this array, but since this is a chunk, we can just look at this chunk right now. And we can do that because since we know if we pick any value in this chunk right here, we won't be able to pick any value in the array, the imaginary array, where there are other arbitrary numbers. So let's just say hypothetically, if we were to pick this chunk, we would have Arseny pick this value right here, then Agor pick this value right here, then Dabir pick this one and Agor pick this one. And then Agor wins because Dabir has no other values to pick. And because of this, we can realize that if the if the amount of the largest values in a chunk is even, then Dabir and then we can have Arseny pick the largest value, and therefore Agar and Dabir can only pick the largest value too. And if the amount of largest values is even, then we know that Agar wins. So amount of largest value in a chunk is even, then the answer is yes. Another thing we can realize is that if let's so we already know if the amount is even, then we know that Agor will win. But now let's think of the case where it is odd. So like let's just look at this chunk right here, 5, 5, 5. Since there's only fives in this array, Arseny can only pick the first can only pick 5. If Arseny picks 5, Agor picks the next one, and Dabir picks the next one. And Agor loses because there's not enough values for him to choose. So we know that if if there are only the largest values in a chunk and the size of that chunk is odd, then we know that Agor loses. But now, what if there were other values in the chunk? So, for example, we had 2, 3, 5, 5, 5. What we could do is we could have Arseny pick this value right here, and Agor could pick this one, Debir pick this one, Agor pick this one, and Agor wins. So this is because we can just act like one of the other values in the chunk that isn't the largest value. We can treat it as a buffer, and because it's a buffer, we can have it in a certain parity so that Agor will win. So we know that if it's odd and other values exist, then we know the answer is yes. And these are the only two things that we need to know to solve the problem. So now we can look at the code. First, we enter in all the values. We sort the values so that we can split them into chunks. And how I do this is I create a vector of vector chunks, and I save the current chunk as the value with the first value. And I do this so that I can keep track of the frequency of all the values, and that's what my map called count is for, or CNT. And I loop through all the values from 1 to n because I already looked at the 0 index. And I add it to the count. Then I check if this current value, the distance between this current value and the last value is bigger than k. And if it is, I separate the values into chunks. And if it's not, I just add it to my current chunk. And at the end, I push in my last chunk. So now I loop through all the chunks to see if there is an answer, and as you see, I create a boolean called false, called found, and I loop through all the chunks. And for each individual chunk, I first sort all the values in the chunk. I'm not sure if this is needed, but it might be needed or not be needed. This right here, and then go through I look at the largest value in the chunk and I check if the frequency of this largest value is even. If it's even, my answer is true. And if it's not even, so in this case it's odd. If it's odd and the amount of largest values is not equal to this chunk of the size, that means the other values exist that are smaller than this largest value, then I set the answers to true. And this is the case right here. And if for either of these the answer is true, I can just break from the function because I found a chunk that works. And yeah, if the chunk doesn't work, then I say no. And if I did find a chunk that works, I print out yes. And yeah, so basically the idea is to split up the question into chunks. And for each chunk, we can solve each chunk individually because all of the chunks are individual. And if I pick one value from a chunk, I am stuck in that chunk, and therefore I can base my answer off of that. So thank you, and I'm gonna put this code into the description, and as you can see, this works. I have the same code right here. And yeah, thanks for tuning in.